people. In this video, we're going to do another example of polynomial long division, but in this case, we're going to discuss a special case, and that is the case where I were to say have a dividend or a divisor, really, but if either my dividend or divisor is not actually written out in, say, standard form of a polynomial equation. So what I mean by this is, you'll notice x cubed minus 1, okay? By not written in standard form, I'm kind of saying that it's not written as x cubed plus no x squareds plus no x's whatsoever minus 1. Of course, why would I write it this way? Like, I value my time. As a matter of fact, I'm a little sad that I took the time to write that out. But the bottom line is, when you do, like, say, long division, just like when you say do addition, okay, your place values, you know, they need to line up. They need to line up. So it is the case that when we divide this time, we are actually going to need to fill in these missing terms. And I know that's annoying, but I'll tell you what, if you'd like to get an A+++ on your math test or whatever it is you're watching this video for, I promise you, you need to fill those things in when you write your long division. Okay, so let's start with this, our dividend. Okay, our dividend is the thing we are dividing. In this case, we're dividing, you know, x cubed, 1x cubed plus 0x squared plus 0x's, minus 1. Don't want to biff that. And our divisor in this case, our divisor is x minus 1. So now, before we start, you know, again, I like to look at the big picture of this thing, and we're probably doing long division in the first place to find zeros of a function. So in other words, like, for example, if x minus 1 was a factor, if x minus 1 is a factor, when we set it equal to 0, we find that x equals 1 is a 0. And if anybody who knows their factoring knows this, x cubed minus 1 is so certainly a difference of two cubes. So it does factor out into x minus 1, and then x squared, I think is going to be a plus, what do we got here? X plus 1. I think I got that right. Geez, I should know this, right? I will tell you this, though. Hopping over to the graph, just to look at this. By the way, 1 is so certainly a 0 of this. Okay, so if 1 is a 0, then what I'm about to divide out, x minus 1, is definitely a factor. And so, you know, just kind of talking about long division again, if that's a factor, it just means that we're not going to leave a remainder. And those are good things to think about as we do this. But the whole point of this video was to discuss this special case, so let's just get on with it, huh? Those zeros right there. So if we don't fill those in, we'd have a problem, but let's talk about we did. Okay, so now I'm asking, okay, so what could we take times x to get it to be this leading thing right here? And the answer to that, of course, is, well, we take x times x squared. So if I put that x squared on top of anything, I better put it over my x squared. So another reason why we need to fill this term in is because we need to line up our place values. So now, taking this x squared, distributing it through our divisor, okay, we get x squared times x is x cubed, that's what we desired, and then x squared times negative 1 is negative 1x squared. So now we're subtracting all of this off. Let's go ahead and change this, change this to a sum. So plus, negative, positive, and add these instead. So these cancel. 0x squareds and 1x squared, of course, that sums to be x squared. We'll go ahead and carry down our plus 0x to take that place, and we'll start again. Okay, so what can we take times this leading thing to get to be this leading thing? We can take x times x, of course. So in yellow here, we'll put our plus x, of course, over our x to the first here. We want to line up our place values. Okay, so x, now let's distribute that x right here, this x times our divisor. So we get x squared, of course that's what we wanted, minus x. We're going to subtract all of this off. So changing this to a sum, we got positive, this will become negative, this will become positive. Adding these instead, those would cancel. 0x's plus another x is going to be x. We'll just carry this guy down, and we'll just keep going until we get to the end. And hey, this one's an easy one. Hey, what could we take times x to get x here? In other words, we're going to take times this divisor to get it to be this thing. 1. Well, we'll take it times a 1. So 1 times anything is itself, so we get x minus 1 over here. And when we take it off this time, of course, we suspected we would have no remainder. To be kind of a, joker about it, but we could technically write the remainder as plus 0 of these x minus 1 things we were dividing by, but that's just me being technical. That's how you would write a remainder. We don't have to write that this time. But the bottom line is that's what would be left over. And you know, over here, it seems I've done my factoring right. So there you are. X minus 1 times the quotient we just got gives us back our original polynomial. And that's the long division we wanted to do. Moral of the video, do not forget to fill in any missing terms in this vortex of missing termness. Enjoy.